better job of promoting it next time myself.
Hey, this is Adam Swan at SOC Prime, and this is our first kickoff webinar podcast event, and we're excited to share some interesting things that have happened in security in the last couple of weeks and talk a little bit about SOC Prime and our new attack view, the website that we have for sub-techniques. It's really cool. So I think we'll just dive right in. So we're going to go over some methods for confusing a lot of detection content when it comes to child and parent relationships. So I'm going to go ahead and share my screen. So I should be seeing a VirtualBox session, and we're going to go ahead and look at some code here. So there's a lot of detection rules out there that simply rely on parent and child relationships. For instance, the most obvious one is something like WinWord launching PowerShell or WinWord launching command. But there's some ways that malware authors can confuse those detections because there's additional methods of getting execution on hosts and not just create shell, which is the most common. So today we're going to go over just two of those methods that attackers have to their disposal to get execution and break that parent-child relationship. So the first one is going to be via COM objects. So I have this little method here or subroutine in VBA that will allow us as attackers to execute something under Explorer. So what COM is just like, think of it as just a way for two pieces of software within Windows to talk to one another, and it's just basically via an API. So software can register these COM objects, and then Windows has all the infrastructure in the background to say, hey, Explorer, Word is trying to communicate with you, and it handles all that communication. So basically you instantiate this COM object, Windows takes care of all that confusing stuff in the background, and then you can just call the methods or do whatever the COM object allows you to do. So in this example, we're going to be using the COM object for shell browser window, and this is a GUID, but it's also the class ID for the COM object. So you can reference this in two ways. You can reference it via this COM class ID GUID, or you can actually reference it via the actual plain name often. So that would just be shell browser window, like that, spelled out exactly like that. So most people like to use the GUID because it's probably the more robust way to do it. So what this does is the shell browser window COM object is a COM object that talks to like a shell browser, which is in Windows is Explorer, and it has the method application.shell execute. So shell execute, it sounds exactly like, or is exactly what it sounds like. It allows you to execute something via, Explorer, so via the shell, which is Explorer in this instance. So if we run this, you'll see the calculator's popped, and we're going to go ahead and take a look at the sysmon log. Here, if I have to refresh it and go down a little bit. So you can see the command line was simply just calc, and it was launched but instead of WinWord being the process, we have the parent image is explore. So think about in your environments what this means. It means if you are simply relying on the CAN logic coming out of the SIM, because like even Splunk and all of them basically have Windows Word launching a child process. That's unusual. In this instance, you know, that's not going to happen. So there's some ways to go and detect this. One of them is oftentimes when an adversary abuses this, there's basically two things that they can do. They can either A, drop an executable and then call it, or B, they can use some sort of interpreted language like JavaScript or JScript, VB script, or PowerShell are probably the three big ones, and they can execute those. So what that the difference with that one will be that, or what you can detect on with that is Explorer launching W script, C script, PowerShell, or command, and then those commands having like very long arguments. So because generally like they'll do like PowerShell encoding, and that will have like an argument length that's very large. So Explorer launching PowerShell, and then the length of the PowerShell argument is like more than 60 characters. Chances are that that might be something interesting to look at. But there are false positives with that. The most obvious one that occurs is when someone has a link file that runs a PowerShell script. Is pretty common for that to be a false positive. But once you, there's only in most environments just a handful of people doing that for automation purposes. So once you kind of know who's doing that, you can just whitelist it and then have better true positive hits. So the other method, and one that we have an actual Sigma rule for, is via image load and sysmon. So let me share that. It's going to take a second to switch to the screen. All right, so via execution, there's inter-process communication is one of the new techniques under the new sub-techniques. So if you go there and you go to component object model on attack.socprime.com, we click on the Sigma rules. We should see, here's the rule, COM-DLO loaded via Microsoft Office product. So this is now free for the community. Oh, forgot to log in. But this will take you to the page with the rule, and it's now free. So any questions or comments? It's going to about that. It's going to be about a 20-second delay. Any comments from Nate or Andre?
Yeah, I think that was pretty comprehensive. So yeah, pretty much with the rule stuff, it's the community access. That's what I wanted also to comment. And I would agree that this would confuse a lot of scene detections, because we're seeing so many rules and logic based on specific parent and child combinations, while here you can actually circumvent it quite straightforward. So yeah.
I guess another comment with this is recently, within the last year or so, more security vendors are caring more about this technique. So it's definitely like the prevention is getting better out there, but it's certainly not 100%. The bypasses for those are pretty simple, or someone just has to find a novel COM application, because the one that I shared is not. It's definitely not the only one. There's pretty famous ones. One with MMC, because that one's really useful for like DCOM, the lateral movement technique, which is actually basically fundamentally the same as what we're doing here. We're basically, think of it as like DCOM, but local, and just to confuse that parent-child relationship. So.
Yeah, I was going to add on the detection and kind of from the database side. So you mentioned length. We recommend, and it's something we've built or I built in the hunting elk, but adding command line length as a separate variable in your ETL or enrichment pipeline, so that you can do those additional queries, command line length greater than 20 or 30 or whatever it is. And then when you couple that, additionally, you could just create a watcher rule, say if you're using Elastic or ElastAlert, or whatever way in your database to create an alert based on rare, rare parameters in here is another detection method, right? So if you're not specifically using a detection rule to this technique and maybe something broader, or, there's another way to do this that comes out, those are simple thing to write in Sigma to then convert to whatever way your database uses an aggregation to look for rare and then alert you.
Right. Yeah. So, and then I think for this also, like, a lot of people look for Explore or like the common, like MMC or Explore launching these processes like PowerShell, WScript and CScript or MSHTA, and then that process having a network connection. Some EDRs give enough context that you're able to write logic like that. So it's another option if you have EDR.
Yeah, and running, and just a note on your, like group policy sort of things, automating things for users logging in. So, as with anything, there's always a difference running something on a, in a single environment or in a testing environment, right, versus the real world. So as with anything, right, you're probably going to have stuff with group policy scripts, but as Adam said, that's something easy to exclude then never see again. But more so, like as I said, with rare, with the rare detection method, you're essentially, the login script should be something that should be running on everybody's computer, or at least a vast majority. And something like this attack method, is probably going to be fairly rare, maybe a handful of users, or maybe it was a really good phishing attack or something and it's 500. But still, if you're in that large of an environment, 500 is going to be less than 5,000 or 50,000.
Right. All right, cool. So there's no questions from the attendees, or I guess we'll move on to the second technique I wanted to talk about with this, which is via WMI. So WMI is pretty famous as well in security for having a lot of features that adversaries can abuse for their own gain. But in this example, we'll be using WMI to launch a process. And again, the parent won't be WinWord. It will be WMI priv SE, which this example I think is a lot easier to detect simply because of you can detect like pretty straightforward WMI priv SE launching PowerShell, launching C-script, launching WScript is something that is pretty unusual, likely to be unusual in a lot of environments. So this one's a little bit easier to detect on, but again, it's another one that adversaries have to their disposal. So in this object, this get object, we're not calling a COM object this time. We're calling an object that exists as part of the WMI service. So when we see this, we'll actually see that the chain is SVC host, and then WMI privacy, and then calculator. So this WinMGMTS is just for literally calling on the WMI object that's in that service. And sometimes you'll see an example like this, and they'll have like a namespace here. Because WMI separates all the classes that they have based off of different namespaces, but the Win32 process object is just in the root or the default namespace, so we don't have to worry about it at all. So just by calling this get object and then asking it to create it, we will create calc. So you might be more familiar with like WMSIC Win32 process create is like the more maybe easier to understand method of using the Win32 process, but this is actually doing the same thing. We're just doing it programmatically via VBA. So let's go ahead and run it. And there's calculator, and let's again go and look at the events that were created. So there's WMI privacy, and we'll go all the way back. Should see. We should see, yeah, here we go. So here's WMI privacy, and you can see that the parent image was SVC host, and then it had the parent command line of this decom launch. So like flagging on this may or may not be useful to you, because it really depends on if your environment is using decom legitimately. If it's using decom legitimately basically at all, you're going to see this a lot. So it's not, it's one of those things that really depends on the environment. But again, yeah, so we see SVC host because that WMI process is, or the object is within that service. So this service is what's handling the communication for us. So WMI is basically uses like almost the same, uses like the COM objects as well. So that's why we see this decom launch business. So again, you'll see WMI privacy launches, and then we should see it launch the calculator. So this one is, I think this is pretty much a straightforward detection. Look for rare or processes with the parent image of WMI privacy with like PowerShell, command, WScript, CScript, any of like the living off the land binaries is probably useful. And then especially ones with longer arguments, because again, or longer arguments are you know, they contain HTTP, HTTPS, GitHub, you know, the usual suspects, or a lot of adversaries are hosting second stage today. You'll have some success. So we again have another rule to share, and it's again, it is on our attack page. So let me pull that up. All right, so you guys can see it. All right, cool. So again, this one's under execution, and this is the new sub-technique view. So you go to WMI, and there are no sub-techniques for this WMI yet. So if you just go to Sigma, you can see that there is a actual community rule that we can use. Oh, that was Blink is broken. Maybe it recently got updated. But we also have stealthy WMI command execution, or this possible code execution macro code without child process. Both of these will allow you to detect this, but unfortunately, since I didn't log in before this webinar, I can't actually show you the rule. Again, I think the attack, like this view, get used to it because everyone is moving to the sub-technique view. So I think this is actually the attack.socprime.com is way easier to navigate than the MITRE attack matrix, which is yeah, it's useful, but this is like so much more compact and it works on mobile. So from your phone, you should be able to get to all these rules. So yeah, it must have recently gotten updated because it was working. Not when I ran the test, but anyways, doesn't really matter. Let's move on. So any comments from Nate or ANDRII about detecting this?
Yeah, I don't think I provided any technical comment on this one, except that that's, WMI we've seen, it's a very common technique that's been, used for the last several years, and there's plenty of community detections you can dive into. So yeah, that's the way I see it. And yeah, also about the attacks, SOC design. So yeah, the whole idea of creating it was like a quickly navigate attack, make sure you can do it even if you're out of home or out of the office and you have some maybe 3G or even edge connection. The page is actually quite small and is cached on Amazon worldwide. So yeah, it's a quick way to search for it, with maybe not specifically relevant to this technique or threat, but nevertheless.
Yeah, WMI has been around a lot. I think Matt Graber in 2015 really opened up the security's eyes to the possibilities. So there's a lot with WMI. If you haven't read his paper, it's available at blackhat.com, and it goes over most of the things that you can abuse WMI for. But this WMI spawning macros, macros using WMI to confuse the parent-child relationship rule. Stuff isn't covered in his paper, but a lot of useful information is in there, all about how WMI works, and it's really good. All right. So we wanted to go over maybe something that's a little newer in the security sphere. So we have the next stuff will be about the command hijack, and we'll go over some of the things that were found about it in the community and maybe some misconceptions that came out of it. And so I'm going to go ahead and share a very familiar screen here in a second. All right, so share. All right, so we're. Let me just send it. All right. So again, we're back in this macros because it's very easy to sometimes the POC stuff in these and understand what's going on. So what is command hijack? Basically, command hijack is just a way to pass a new executable as a parameter to the command prompt. So the example that the researcher, Julian, and I'm going to butcher his last name, Horowitz, I believe, maybe, discovered this while doing some reverse engineering of command, trying to find new attack parameters. And his use case was that some web components, web servers out there, use command to do things like ping. So for instance, you might write a simple web page that takes an IP address and then via PHP shell execute pings that IP address for you and returns the results. Well, he identified this method of sneaking in some additional information to the command shell, and it enables you to sneak in an alternative executable. So let's go ahead and run an example here. Let me try to get this a little bigger. So here's, don't want all this. So here's command hijack. And you can see you can run it, you can pass it a parameter. So in this example, I passed notepad test, which is a simple text document with just it worked in there. But you could obviously, like, this could be PowerShell and this could be, you know, a malicious script. So it's kind of introduced a vulnerability to some systems that use the shell execute from a web app, but also, and from a defender's perspective, you might, or from an attacker's perspective, there are other things that to worry about, because different SIMs treat these things differently. So, like, some SIMs, for instance, they might have a word limit on how much data they can put into the command line field. So maybe that limit is 200. So what an attacker might do is just add 200 rows of, or 200, this is actually like a directory traversal that's occurring here. So he might add 200 of those and just blow out your SIM's ability to, for the detection content to actually flag on this sort of activity. Excuse me, sorry. So that's just one method, and really it depends on the SIM. So, like, certain SIMs, for instance, with that do tokenizing, like ping here, will just be if you, for instance, in Azure Sentinel, you use like command line has ping, this will break because command line has ping will not hit, because in the tokenization it'll have ping 127, which is not ping, and therefore it won't match. So really, like, this sort of whenever you can, like, cause some confusion in the way that parameters are passed and what was being logged as an attacker, like, you can really start breaking down, like, people's detections, because people who write these databases are concerned so much about performance, and they want you to use has instead of contains. But it's something to really think about, like, are there methods to confuse that tokenization or not? So I thought that this is an okay example to show how that can happen. So Advor, I think it was Advor Mo. Yeah, go ahead.
Sorry, I was just wanting to say, on the SIM side of things, it can mess up a lot of things. So not just the end correlation rule as a condition, but if you think about the whole journey that data makes it to the SIMs, then parsing can break, right? Because most of the SIMs use regex, and if it's not written correctly, just with this construct, it can break a lot of regular expressions. After regular expressions, we get normalization, which can break, and then filtering can break, and then, yes, like you mentioned, the database maybe it doesn't have enough room to fit in the entire stream, and then we go to the correlation layer. So yeah, pretty much that's a very cool method to bypass different detection and sneak in the command execution into SIM and the payload name as well, right? So yeah, that's a very quite a tricky method to detect with most of the SIM. I mean, even the next generation SIMs, but even the old school ones could still run MySQL in the backend in one way, shape, or form. They will have a trouble with detecting that.
Yeah. Yeah, it's really, you really have to, like, know your SIM and exactly, like, know your parsers to understand, like, how this sort of thing can affect the end result. Like, it is something that I think is going to flag, going to flag. So like a famous example that we talked about kind of recently in a blog post was Elastic's keyword fields. So keyword fields are case sensitive. So a lot of Sigma rules were breaking because like, you would have PowerShell, but if the attacker just capitalized the P in PowerShell, all of a sudden the detection broke. So we rewrote, or Nate helped and I helped rewrite that so you can actually export to a case-sensitive regex to fix that. But these sorts of problems like that exist in most any SIM. So you have to get used to understanding the nuances that's there. So that's one example. Another example is the has operator that everyone wants you to use in Sentinel. It relies on the tokenization that's mostly based off of like spaces and symbols are dropped. So it exists again like in older SIMs and also in the new next generation stuff, like ANDRII said. So the next example is basically that this works with conhost, and I think that this conhost hijack is really interesting because only recently did conhost allow you to spawn a child process, but in this example we're using conhost and we're using with the command hijack technique. So recently, within the last security update, I was not able to reproduce command hijack as of the latest security package that came out last Tuesday. But it still works with conhost, and a lot of people out there are whitelisting conhost because conhost is probably the #1 most spawned process, and 99.9% of the time or more, it's completely benign and normal because it's the console host. It's provides like the subsystem access for console applications like command prompt, but you'd be surprised the amount of GUI programs that also launch conhost because they're really not GUI programs. They're using the console subsystem to create the GUI and everything. So it's really super common to whitelist this because it's so very common on networks. So with I think it's doubly dangerous now that it's susceptible to this technique of the command hijack. So it's the same exact thing, and I'll just give a quick review. So one misconception that I think made it onto some Reddit threads and in Twitter was that this breaks, that the conhost method might break the parent-child relationship. And that's true to an extent. Like if you're looking at it with Process Explorer, I was able to see that, yeah, it looks like the parent process is not available, but in Sysmon is not the case. So if we go and look, you should see, yeah, that conhost was the parent image. So if you have conhost whitelisted, I strongly suggest that you go back and change that whitelisting so that it's looking at the command parameters. There's so that you don't whitelist when conhost has exes in it. Because if you have conhost and in the arguments is an exe, chances are it's going to be malicious. So that's one way to detect this attack. And then obviously it's pretty easy if the data makes it into your database correctly to detect on the directory traversal as well. So that covers the two techniques, or I guess the three techniques. We talked about WMI, we talked about COM, and then we talked about command hijack and how it affects systems. So if there's any questions about that, I'll give some time. If you can use the Q&A feature, and it's open. I'll just wait a minute or two Nate or Andre, do you have any comments or?
Yeah, I think that was very good coverage, and yeah, I just want to once more stress that since with detection in engineering and with threat hunting, there is never a static status, and you need to keep up to date. What's been a norm for years maybe is not a norm anymore, right? Because of all the agile software development and we could say agile threat development in a way. So yeah, it's important to keep an eye on such things. Just a generic advice.
Yeah. A lot of us like live in the Twitterverse and are also doing our own research and pulling samples and looking at SOC Prime, like looking at what's happening today. The newest techniques, and sometimes we get lucky. I think with command hijack, we got lucky because we have almost everyone has the ability to collect command line details, and it's pretty obvious if it's making it into your SIM. You can detect it basically based off the directory traversal appearing. So if you see 3 or 2 or 3 of those direct slashes in a row, you're probably looking at a command hijack. So the last thing that we have is actually a challenge that we wanted to share, and if someone completes it, basically you'll get kudos from SOC Prime. You'll get kudos. Sorry, Nate, go ahead.
Yeah, I was going to say for the challenge, sorry, about the different databases, tokenization. So just expanding on tokenization is the easiest way to always understand it is like you take a book or, human writing some sort of language, right? You have in the English language, like the quick fox ran or something, right? And there'd be a space between each one of those words. And so a token would be each one of those words would be in the backend database its own value. So when you do a sort of search like has or a quote search for fox, right, it's going to return an exact match. It's a really fast, really easy way to sift through a massive amount of data, very similar to how Google works, right? If you just type in the word movie, Google, I imagine, without having worked there and worked on their backend database, has the results of different web pages, has the word movie as some sort of value or token in the backend database, and thus allowing, instant results. So as Adam said, when you start messing with spacing, capitalization, a lot of databases will essentially, lowercase the values, again, for search speed and just for potential typos and finding things. Again, that's more common for like a language versus computer language or computer code. But this is something, I think if adversaries aren't doing this already, like they don't have a database engineer or, some sort of analytical database person on their team or however they operate, then I would imagine that eventually there will be, because it's not difficult to know what database an organization has, right? Like you can just look up for job postings, does XYZ company have the company have Elastic or whatever it is, so, or Splunk or whatnot, and then figure out how that operates. I think this is another reason why going into like command line length, if your database doesn't store after a certain amount of characters, being able to filter, let's say you only store 1,000 characters, being able to know if there's any command line parameters above 1,000, then I need to go back and potentially look what wasn't stored within my database. when you start getting these really complex characters and stuff, again, like hashing the command line is really good. If you have a 10,000 parameter command line running, that exclusion or inclusion can be a really heavy process, right? And is more likely for the database to muck up or mess up the parameters and escaping and whatnot. So if you're just excluding or including based on the hash of the command line or the length and those sort of things is going to be a lot more efficient way.
Yeah.
I wrote a couple of Sigma rules while you were talking on 2 of those things. So maybe share those later.
Cool. Yeah. The one thing like that Nate and I almost, we really like agree with is it's really nice to have these more these fields and your sims today that are faster, like when it comes like they're I'm drawing a blank on a simple word, but anyways, that they're more efficient. That's the word I was trying to think of. These really efficient fields that you can do fast searches on that are tokenized, but we're like it's always a good idea to keep the value of what was sent to the database from the data source in the rawest form possible, as close to what occurred on the box. Like a lot of people might normalize things like user agent strings and make them all lowercase and stuff like that, but there are definitely detections out there that that exist that are just basically when an adversary capitalized the Z in Mozilla and stuff like that by accident in their malware. So there's it's best to keep when you can as raw as possible as an option.
Yeah, or even giving your steps of within, like what steps were taken on certain values. So, as an analyst or incident response or whatever it is, right? That when you're looking at this value that it had potentially been modified or or what was the enrichment or ETL process that value had taken. There's a lot more to look into this than people think, right? Like Adam and I have always kind of gone around, at the lowest form, we can just bypass detections, with capitalizations or spacing or special non-ASCII characters or length and those sort of things, right? Like you don't even have to have anything advanced if you're just able to bypass logging or detection entirely. So like I said again, if adversaries aren't exploring this, then I'd be surprised if they're not in the near future, right? So no need to even have advanced malware or whatever it is, just, okay, let me add 14 spaces, something that a cat walking across the keyboard could do for you, or your young kid, when you walk away, can jam on the keyboard and create quote unquote advanced logging bypasses. So
yeah, and a lot of the times, it happens anywhere in that chain. Like Andrew was saying, it could happen in the parser, it could happen could happen on the endpoint itself, it could happen in the delivery, and then the parsing, and in the database. It's best to have an idea of what's happening to your data at each step to know what could go wonky. So yeah, we have a challenge. We're gonna do a weekly challenge, and every week we'll or when we do these podcasts, the next one we'll go over how to solve it. But this is an open challenge. It's pretty. This one we kept it pretty light and easy, I think, with lots of hints. So it should be pretty plausible to do it. So here it is. It's on my personal GitHub, but also I added the link as an announcement, so it should be within the Q&A section of the Teams meeting, you should be able to get this link, and then I'll also I'll tweet it out. My handle is at ACALARCH, so ACALARCH on Twitter. I'll tweet out the challenge. So again, the challenge is, this is obviously base64 encoded text, and the ciphertext is encoded with a Vigenère cipher, and the challenge is to tell me what is the key. And then here's some useful hints, and best of luck on that. So any closing remarks, ANDRII or Nate?
I think it was pretty cool. Sorry, I just kind of disappeared when the connection broke down as we recorded. Yeah,
okay.
that was, yeah. As I said, that was pretty comprehensive. So look forward to continuous discussion, and we can probably start planning for the next one.
Yeah. So yeah, stay tuned. Look for on our Twitter, or if you signed up for this one, you'll probably get a notification that we're holding another one in a couple of weeks. So we look forward to having you again, and I'll definitely look forward to, if you have any feedback, you know, send it to SOC Prime, you know, at any of our social media, or you can contact us on our website and let us know if it was useful or anything like that. So, all right, thank you.
Thank you, Adam. Thank you, Nate. Thank you, everybody, for watching this.
Okay, thank you.